So if there was anything over on the notes last night that didn't make sense, I can certainly answer questions. How did we feel about domain and range for polynomials? Good? We're good? Okay. So the range can definitely change for a polynomial depending on if it's an even exponent or not. If it's odd, you're going to have all real numbers, though. Increasing, decreasing intervals, how did we feel about that? We're good? We can do those? We're okay? All right. So, and we figured out that the maximums and minimums, there's a lot more of them than we're used to seeing, and so there's a lot more increasing and decreasing intervals with polynomial functions than we've ever seen before. So it's going to be really important, especially on these. Jessica, you should not be texting. Thank you. You're going to have a lot of answers for these, basically, and a sketch is going to be particularly helpful for this unit, definitely. For maximum and minimum, that's what we're doing together today because we're going to look at funky answers that can show up on the graph. So maximums, we're looking for mountaintops, any little mountaintop on the graph, and, sorry, I'm going to highlight it, there can be more than one. So that's important that you don't have like the highest point. This is not like an absolute thing. It's just relative. So any point on the graph that looks like it's a little bit of a high point, it's a little mountaintop, those are relative maximums, and that's what we're finding. Minimums are valleys, any little valley on the graph, and there can be more than one. So it's a relative thing. It's just a low point relative to that area. All right. So the example problem is on the back side of the page, and we are all going to be typing this in. So go ahead and get your calculator out, because something weird happens, and I want to show you guys what it is. Okay. If you're using one of my calculators, or if you have used your calculator for science class lately, you might want to clear the memory. So second plus 712 will clear the memory for you if you wanted to do that. And we can go ahead and type it in. X to the fourth minus x to the third minus 4x squared plus 5. And then that's what your window should look like. That's a normal window. It's about the same as the window that we have for this example problem. Looks like this. Okay. If you are working on a problem today and you feel like the graph is just a little bit small, you can't see it quite as well as you want to, I am not a fan of the zoom function on the calculators. I don't think it zooms very well, so I just like to take my window and kind of zoom in manually. So on this one, maybe I would do, maybe by like 5, I could do -5, and just change all those from 10 to 5 instead. And then that would give the appearance of zooming in. There we go. And right up here, if I don't like that put the maximum right there at the top, I could change, that's my Y max. I could change my Y max to be a slightly bigger number so it's not quite at the top. Maybe change my Y max to 7. There we go. So now I'm a little bit more zoomed in. I can see things more clearly. So you can mess with your window if you want to see things better. -10 to 10 for the X-min and X-max, and Y-min and Y-max are normal, but you can always change it. Okay, any questions about that? Messing with that stuff? Okay, so we have 2 minimums and 1 maximum on this graph. So I'm going to go ahead and label them in the picture just so that we can make sure on our notes we know exactly what this is. So we've got a minimum and a minimum. And right up here we've got a maximum. So how do I use my calculator to find those points? Anybody? How do we get to the menu? Yeah. Yeah, I go down to 3 or 4, whichever one. Okay, which one do you guys want to find first? Maximum. Okay, so the maximum is right here in the middle, so we're going to go to number 4. And then you can scroll or you can plug in numbers for your left bound, right bound. So here's, I'm on the left side. Over here, I'm on the right side. And this is actually exactly why I wanted you guys, I wanted to do this one together instead of having it in the video. So go ahead and find it on your calculator. Mine says negative 5.768 for the x coordinate and then 5 for the y coordinate. And then what do your guys' say? So different x coordinate for you. What does yours say, Ava? Perfect. So negative 1 point something. Anybody else say something different? 2.9. Yeah, so what we all have in common is we all have an E. Everyone see that? You have a decimal. All of our decimals are probably a little bit different, and then we all have the E there. So the reason that we all actually have the same number, our calculator is struggling with accuracy. So we have a complicated function. This is a polynomial. It's a more complicated polynomial. So it's not just x squared or x. It's something that's a little bit more complicated. And as you get really close to 0, you're getting smaller and smaller and smaller fractions. So your calculator is having a hard time having a level of accuracy that allows it to get close to 0. Okay, so what it did is it gave us a number in scientific notation that's actually very close to 0. So what I want you to do is we're going to write this on our paper because hopefully it's going to make you remember it. So I'm going to write my decimal. I want you to write your decimal. Okay, so my decimal is negative 5.768, and then mine says E, and when it says E, that's the scientific notation, so the E means times 10, and then mine says negative 7 after that, so that's times 10 to the negative 7th. So that's what's written on my calculator. Yours might be a little different, okay? Because all of our calculators had a struggle probably, but all of our calculators struggled a little bit differently, okay? So with that scientific notation, that means mine was to the negative 7th, so I'm going to take my decimal and I'm going to move it 7 places to the left. So if yours was to the negative 7th, you'd move it 7 places. If yours was to the negative 6th, you would move it 6 places. Okay? So I'm going to move it 1, 2, 3, 4, 5, 6, 7. That's my decimal. So I had negative 0.00000 5.768. So if you saw that on your calculator screen, what number would you say that is basically your calculator trying to say? I'd say my calculator is trying to say 0. Does that make sense? Okay, so look at your decimal. What is your decimal really close to? 0. Yours is saying the same thing. So the maximum is actually an x coordinate of 0, a y coordinate of 5. Our calculators are just having a hard time. Does that make sense? You should just put 0. You should just put 0. Now, if you are not paying attention, it is very easy to miss that. Okay? Now, if I looked at this, it would be easy for me to write negative 5.768, comma 5, and just write that down as my maximum. There is no stinking way that that is a point that has gone to the left 5.7685 points, right? There's no way that's moved that far to the left. That's clearly 0. So you have to pay attention. You have to notice when the E is there. I have never noticed that to happen for a number other than 0. It is always 0. Okay? It's never another decimal. Your calculator will struggle with other numbers to a decimal place, but it will be like 1.999999999, and your calculator is struggling to say 2. So in other situations, it's obvious. This is the only one where you have to pay attention. Does that make sense? This is not a gotcha moment. This is one of the just technology. This is a technology glitch. Of just like calculators are wonderful, but this is one of the hard parts about us having a calculator that's worth $100 versus us having a calculator that's worth $10,000. Does that make sense? So because we have cheaper calculators, we have to deal with this as just like, yep, that's just what they do, and we deal with it, and we just kind of work with what we've got. So it is fair for me to give you a question where this might happen, and you should recognize it, and you should be able to say 0 correctly. Make sense? And that's not me tricking you because it's a very common occurrence. It's something we just watch out for. Make sense? The more complicated the function, the more likely it is to happen. Okay? So it's common anytime you have something, notice specifically this was the y-intercept. It's a maximum that happens to be the y-intercept. So just be on the lookout. It's going to happen multiple times today. Okay? Just something to watch out for. All right, the minimums are normal. We can find those. Those aren't going to be hard. So let's go ahead and look for those real quick. So first minimum, get our left bound, get our right bound. Negative 1.088 for the x-coordinate, 2.954 for the y-coordinate. And then we can get the other one. (1.838) negative 3.310. Okay. Was everyone able to find those minimums okay? All right. Go ahead and take your notes, flip them back over to the front page one more time. So when we write these answers, we are typically going to write them as an x and a y coordinate. However, when you are doing EOC questions or maybe even ACT and SAT questions, it would not be uncommon in a multiple choice setting for them to say, where is the maximum located? For them to ask a where question. And instead of giving the answer as an x and a y coordinate, for them to only give you one number. And when they do that, they're talking about the x value. If they say, where is the maximum located, they're talking about the x value of the maximum. If they say, what is the maximum, they're asking for the y coordinate. So it would not be uncommon and it would not be crazy in a multiple choice setting for them to ask a question like that and only give you one number. I don't like questions like that. I think that it's kind of getting at like the English side where it's like semantics, where you're just worrying about like what a word means. And I'm like, this is math. Just let us do the x and the y coordinate and not be, vague about it. Just let them do both. But it is fair in a multiple choice setting like that for them to make you know the difference between where something is and what it is. And that's what they mean. Where is an x value? What is a y value? I'm not going to ask you questions about it because I don't like those types of questions, but they are fair game in standardized tests. So I'm going to continue to remind you that that's what they mean. Okay? Are you going to get it from me? No. When we answer those questions, feel free to put the x and the y. I will always give you full points. Make sense? Okay. So for today's assignment, there are plenty of questions. I'm not going to have you do all of them. So there's two columns. There's odds and evens. For the front side, I only want you to do the odds, okay? And then on the back side, we have these problems that you guys love. Don't you love these? Your faces, I love it. For these, I want you to do all of them, okay? So the front side is odds only. The back side is all, okay? So we're going to start the period working on this stuff, and then towards the end of the period, maybe the last 30 minutes or so, we're going to go back to the stuff that we were doing yesterday with writing equations. And if you guys need me to talk about number 6 from last night, I'm guessing 1, 2, and 3 were okay, but if number 6 we need to go over, we can. And then we're going to go over some more of the examples from the notes. Okay? Sound good? All right. So do odds only, answer keys in the back, and then all the problems on the back of this. Alrighty? Okay. I'm going to hand these. Okay, so here is number 6. It's a quadratic. That's the hint they gave us. We know that a quadratic is y equals x squared. That's how a quadratic starts. And so that means a quadratic has a degree of 2, which means that a quadratic would have 2 solutions. So I know that when I start this problem, I'm going to have an x equals and an x equals. I know that right away. It's a quadratic. Now, if one of the answers is 4 square root 11, then because it's a radical answer, I know that that answer must have come from the quadratic formula. So if I look up here, I can see 4 square root 11 must have come from right here, and right in front of the quadratic formula is the plus minus. So if positive 4 square root 11 is one of the solutions, then the other solution must be negative 4 square root 11. Does that make sense? Because they always come in pairs. So if I have the positive version, I must have the negative version. Okay, so that means I've got y equals, and then I have to start writing my parentheses. So I should have x minus 4 square root 11, because I always have to do the opposite sign when I put it in the parentheses. So the positive answer gets the negative when I put it in the parentheses. And then I should also have x plus 4 square root 11, and put that one in the parentheses. Good so far? Okay. And then at this stage, I should be foiling things, and it's going to look a little bit messy, and then everything is going to clean up really nicely, because that's how it always works. So when I start to FOIL, I have x multiplied by x gives me x squared. And I have x multiplied by 4 square root 11. And we always put the numbers in front of the variable, so that would just be 4 square root 11x. And then we have negative 4 square root 11 times x, which is negative 4 square root 11x. And then the next one is negative 4 square root 11 times positive 4 square root 11, and this is a flashback to Math 2. So we do negative 4 times positive 4, which is negative 16. And then we do root 11 times root 11, yeah, which is root 121. And root 121 is 11. So we have 16 times 11, which is 176. Okay, so when we do this, we end up with positive gross and negative gross. And what happens with positive gross and negative gross? They cancel, thank goodness. So those are gone. And so we end up with y equals x squared minus 176. It ends up looking really nice. And you don't even know it was gross in the middle. Okay, so there's our problem. That's what number 6 should have been. Okay, let's go back to our notes, and we're going to see how we should do a problem with eyes in it. Not eyeballs, don't worry. Imaginary numbers. Did you think there was going to be eyeballs on the problem? No? Anybody? No? Tough crowd. It's rough. Rough. Not even like a pity chuckle. Nobody. All right. Next example. It says a second degree polynomial. So how many answers are there? 2. X equals and x equals. There are 2 answers. X equals x equals. And it says that one of the roots is negative 3i. So, we've practiced an assignment where we started getting those complex roots as answers. If one of the answers is negative 3i, what must the other answer have been? Positive 3i. Yeah, that's how it works. Okay, so if one of the answers was negative 3i, the other answer was positive 3i. All right, you guys want to do y equals g of x equals f of x equals h of x equals y equals? Okay, so we got y equals, and then we got parentheses, parentheses. So if my first answer is negative 3i, what should go in the parentheses? X plus, right, we do the opposite sign, plus 3i, you're fine. And then if the other one is positive 3i, what should go in the parentheses? Minus, perfect, x minus 3i, okay? And so now we FOIL. We got x times x, which is x squared, x times negative 3i, which is just negative 3ix, which is weird. Then we got positive 3i times x, positive 3ix. And then we have positive 3i times negative 3i. What's positive 3 times negative 3? Negative 9. And then what's I times I? I squared. And do you remember what I squared is? It's negative 1. So this is negative 9 times negative 1. And negative 9 times negative 1 is positive 9. Okay. And so then up here we have negative gross and positive gross. And what does that give us? No gross. All the gross is gone. Okay. So we end up with y equals x squared plus 9. Whew, thank goodness. Okay. How do our brains feel? Pretty good? We glad that the gross goes away? Oh, thank goodness. Okay, next problem. Find the standard form of the equation of a third degree polynomial. So how many answers does this one have? 3. So we're going to write x equals, x equals, x equals. And it tells us that the roots are negative 2 with a multiplicity of 2 and 1 with a multiplicity of 1. Are there any radicals or any i's? No. So that means we don't have to worry about pairs. We don't have to worry about, oh, there's a minus sign, there must be a plus sign, because these answers did not come from the quadratic formula, they came from factoring. So I don't have to assume anything about this problem, I read it as it is. No assumptions. Okay? So it says negative 2 with a multiplicity of 2. What does it mean when it says multiplicity of 2? That was squared. That answer happened twice. Okay? So negative 2 with a multiplicity of 2. That same answer with the same sign happened twice. Make sense? Not a plus minus, no, because it didn't come from the quadratic formula. It's exactly the same answer happening twice because it came from factoring. Okay? And then it says 1 with a multiplicity of 1. So just 1. All right. Are we sticking with y equals? We're feeling solidly about y equals. Last period, instead of doing like g of x or f of x, we did panda of x. And let me tell you, my pandas are not very good. I tried. I tried really hard to draw a good panda of x. And then the next problem, we were going to do tapeworm of x, but I don't know how to draw a tapeworm, so I did earthworm of x. So if we want to get more creative on the next one, I'm just letting you guys know that's the standard. Okay? Panda and earthworm, you guys be thinking. Okay? The challenge is out there. All right. What do we put in parentheses? Anybody? Okay, x plus 2. Now I could put it squared, but I'm not going to condense it like that. I'm going to leave it expanded because I'm going to FOIL. So it's kind of nice to have it expanded out. But having x plus 2 squared is not mathematically wrong. It is correct. Yeah. Perfect. And then x minus 1. All right, so now what should we be doing? We should be foiling. Which ones do you guys want to foil? X plus 2's? Okay, so we're going to FOIL these two. I mean, you guys have the power to choose, so we can get creative here. No? Nobody's feeling like this is fun? No? Okay. I mean, I tried to make it exciting, but if you don't want it to be exciting, that's fine. Okay. All right, x times x, and then 2x, and then a 2x, and then a 4. So this is exactly like the examples that we did yesterday, but yesterday we had a picture of a graph, and today we just had like the verbal description of a graph instead. That's the only difference, is that that's what we're looking at. Okay, so now what do we do? Yeah, we're going to multiply. We're going to go ahead and use a box because it's easier. If you like to FOIL, you are welcome to FOIL this. I just am not someone who likes that. So we've got 3 terms times 2 terms. I'm going to do a 2 by 3 box because that fits my space easier. So we got x to the 3rd, 4x squared, 4x, negative x squared, negative 4x, negative 4. Okay. Did you guys get the same thing at the very end? We are all in agreement. Yes. Okay. If you guys are feeling good about that, we have a more difficult problem to do next. Are we feeling good about this? We feel like this was reasonable. We got it. It's in our brains. It's in our hearts. No? You guys are like, Miss Rice, stop it. Just do the math. Move on. Okay. If you look at this answer, does this look like the answers that we were having the other day when we did that assignment? You guys remember the Will Smith assignment? So 2 plus 5i is a pretty common answer. It just means when I'm going to write out the quadratic formula, you don't have to. I just want you guys to see it in front of you. So we would get an answer like this if we had a number here and then we had a perfect square here that was negative, and then those two numbers were both divisible by what was on the bottom. Do you guys remember that happening a bunch on that assignment? And so everything kind of simplified to some nice clean numbers. Okay, so if 2 plus 5i was one of our answers, what would the other answer have been? 2 minus 5i. Yeah, so the number where you have like the pair, where you have 1 plus and 1 minus, it's not the front number that changes signs, it's the number in the middle. Because the plus minus is in the middle of the quadratic formula, it's not in the front. Does that make sense? It's the middle number that changes. Okay? So that's something to remember when you get your pairs of numbers, that it's the middle. It's the middle of the pair that changes. Okay, so they're asking us to do the standard form of a second degree polynomial. So we've got 2 answers, which makes sense because we only had 2 possible answers with the information they gave us. So we have 2 plus 5i, 2 minus 5i. All right, should we do y equals f of x equals g of x equals? Can I do what? You can't do the same letter. That'd be confusing. You guys have no creativity. See, you guys are like, let's just stand here. All right, I'm gonna do gauge of x. Okay, it is gauge of x. Okay. It is. His hair is curly.
It looks like he has like hair rollers.
That's what I was gonna say.
I mean,
I think I could look like this. I don't.
to be fair, it's also how I draw myself. So you and I have the same stick figure hair.
Yeah.
Mine would be slightly longer, but only slightly. So in stick figure world, our hair is like inches apart. You said it's giving shower cap? Okay. Curly shower cap? Let's move on. All right, so the first set of parentheses. Now, be careful because we have to change the sign of everything. So make sure you change the sign, okay? So we got x, and then change the signs, and what would you have? Yeah, perfect. Okay, because when students make a mistake on this part, they either have no clue how to do the problem, or they mess up the signs when they put it in the parentheses. That's how students do these problems wrong, this specific type, okay? And then the other parentheses would be what? Wait. Change the sign. You got to change the sign when you put it in the parentheses. Change the sign. Wait. Look at the sign of the 2. There you go. Plus 5i. Perfect. So just make sure you change the sign when you put it in the parentheses. Now, what I will say is students who do not write this first, students who try to put it straight into the parentheses almost always get it wrong. Okay? Now, you can think you're the one exception. You're probably not. I'm not daring you. I'm just telling you. I'm telling you how it is. Okay? I've been teaching for a while. I'm just letting you know it's not a dare. I am not daring you. I dare you to not show I dare you to show your work. How can I reverse psychology this? I dare you to not show your work. Are you confused? Please just show your work. Please just show your work so you can get it right. There's no reason to get this problem wrong because you're trying to save yourself half a second of time. Just write it out. Okay? All right. Now, do you guys see how this is 1, 2, 3 terms times 1, 2, 3 terms? There's no foiling for this one. We go straight to the box. That's right. No foiling. There's no foiling on this one, and there's a whole lot of gross. But what happens when we have gross? It cancels out. The answer looks nice in the end. I promise. Okay? If it doesn't look nice in the end, it means you made a mistake. Okay? No mistakes. All the gross is gonna go away. I promise. All right. X times x is x squared. X times negative 2 is negative 2x. X times 5i is 5ix. Negative 2 times x is negative 2x. Negative 2 times negative 2 is 4. Negative 2 times 5i is negative 10i. Negative 5i times x is negative 5ix. Negative 5i times negative 2 is 10i. And then negative 5i times positive 5i is negative 25i squared. The I squared is negative 1, so this is negative 25 times negative 1. Negative 25 times negative 1 is 25, and so this is just 25. Okay. Now, we have negative gross and positive gross, which is nothing. Okay, so we'll cancel those out. And we have positive gross and negative gross, which is no, we'll cancel those out too. Okay. Okay, so we have gauge of x, shower cap gauge of x, equals x squared minus 4x plus what? 29. Perfect. Gauge, that is your new equation. It means your life. It's significant to you somehow. I don't know how, but it is the meaning of your life. Okay. So take the assignment from yesterday. Yesterday we did 1, 2, 3, 6. Now we are doing 4, 4, 10, 14, 4, 10, 14, 4, 10, 14, 4, 10, 14. So you should have 1, 2, 3, 6 done. 1, 2, 3, 6. And now we are adding 4, 10, 14. We are slowly but surely going to finish that assignment. 1, 2, 3, 6, 4, 10, 14. Now, you are finishing those 3 problems, and I'm giving you some notes for the video tonight. Is that reasonable? I will scan everything you need. For what? Yes. Is that very close to being done? Are you pretty close? Hopefully we're close.